Dear student, in this video we see that properties of intermediate. Actually, the intermediate, the carbocation. The first one is a carbocation, and there is a second category as a carboanion, and the third category as a free radical. These three are most needed or is must for NEET and JE. Okay, so the carbocation last video we studied. In this video, that's the carboanion. In generally, this carbocation and carboanion and the bond heterolytic cleavage. But the free radical in the homolytic bond cleavage. Okay, so now the second type is a carboanion. This carboanion actually there is a the carbon atoms attached with the strong electropositive character. For example, CH3Li. There's a methyl lithium. This for that methyl lithium, and there is a RNGX. This for that Grignard reagent. So whatever that here, this carbon containing this hydrocarbon come to the negative charge. For example, CH3Li. After that, it will separating the CH3 minus plus Li plus A, because the metal is a highly electropositive. Whenever that metal is a positive charge, the remaining part of that molecule that will become there's a negative charge. Okay, so here there's a depends on that negative charge on the carboanion. The number of the carbon atoms attached based on that. There's a primary, secondary, tertiary, like that we can classify it. For example, the CH3 CH2 minus, this carbanion containing this negative charge containing this carbon is attached to only one carbon. That this is a primary carbanion, and there is a CH3 CH minus A and CH3. This carbon is attached to this carbon and this carbon. Okay, so that's why there's a secondary carbanion, and the CH3 CH3 minus, this carbon is attached to 1 2 3 3 carbon. So that's why there's a tertiary carbanion. Anyway, there is a primary, secondary, tertiary, like that it is also classified. Okay, so this carbanion of its stability order, actually the carbanion, there is a CH3 minus methyl anion more stable, secondary, so first primary, secondary, then the tertiary. So this is the order of the stability of carbanion. This order actually there is a inverse of the carbocation as well as a carbo-free radical stability order. Okay, the next there is a structure. The structure of carbanion. In generally, this carbanion, for example, CH3 minus, this become to the sp3 hybridization, but this negative charge behaves as a lone pair. Okay, so lone pair is considering as 1. So therefore, sp3 with one lone pair, that will become to the pyramidal shape. So there is a carbon. This sp3 means there is a tetrahedral skeleton. This is tetrahedral skeleton. 3, the hydrogen is directly bonded. 1 is become to that negative charge. So this will become to that there is a ammonia like a pyramidal shape. Okay, so this is a shape or there is a pyramidal shape, and the geometry has become to the tetrahedral geometry, because it is a tetrahedral geometry. Based on that, it's a sp3 hybridization. And that free radicals, these free radicals are based on that the homolytic bond cleavage. Then homolytic bond cleavage. Okay, homolytic bond cleavage, there is a gives and that free radical intermediate. For example, the CH3 this ethane in presence of photochemical condition, this 2 electron of 1 is become gain this methyl group, and the remaining 1 is become to this gain methyl group. So that's why there's a 2 CH3 dot A. Okay, this is the methyl free radical. Here also there is a depends on that the methyl free radical group attached to the number of carbon. Based on that, there's a primary, secondary, tertiary, like that we can classify it. Okay, so there is, for example, the CH3 CH2 dot A. This free radical containing carbon only attached to this carbon. That's why there's a primary free radical. And see this CH3 CH and CH3 dot here. So this free radical containing this carbon attached to this carbon as well as this carbon. So that's why there's a secondary carbo free radical. And also the CH3 CH3 this carbon is containing free radical. So actually this carbon is attached to 1 2 3 carbons. That's why this is a tertiary carbo free radical. So overall it's a stability order that is equal to, there is a tertiary is a more stable, secondary, primary very lesser for that methyl free radical. Okay, so this carbo free radical means there is a almost similar of the carbocation stability order, and as well as inverse of the carboanion stability order. Okay, so this carbo free radical means free radical as well as is considering electron deficient species. Okay, so the electron deficient species act as a electrophile. For that reason is possessed there is a sp2 hybridization. So NVA sp2 hybridization means that it become to the trigonal planar as a geometry. So for example, in the case of methyl free radical CH3 dot, here there is a carbon and hydrogen. Okay, so this for that trigonal planar skeleton, this become to that only one orbital containing one free radical electrons. Okay, so this is a add electron species as well as it's electron deficient species. Okay, the overall the relation for that carbocation and free radical carboanion. First of all, there's a carbo free radical, and here there's a carbocation and there's a carboanion. So this overall relation, actual this carbocation and carbo free radical act as a Lewis acid. This act as a Lewis acid and this act as a Lewis acid. The carbanion become to that Lewis base. Okay, the Lewis acid Lewis base depends on that number of electron gain or number of electron donation based on that whether the compound or species act as a Lewis acid Lewis base, like that we will study that equilibrium unit. Okay, so this actual it's a hybridization, sp2 hybridization. This also sp2 hybridization. Here there is a sp3 hybridization. So sp2 means actually it's a geometry. There's a geometry, it's a trigonal planar as a geometry. Here is a trigonal planar as a geometry. Here this is a almost there is a pyramidal shape. Pyramidal shape. Okay, pyramidal shape is similar like of ammonia. Actually it's a bond angle is a 120 degree. This bond angle is 120 degree. Here there is a bond angle is equal to, that is for 120 degree, and for this pyramidal shape of this bond angle is equal to 107 degree angle. Okay, it's a formation. It's like for example the CH3Cl in presence of photochemical condition we get the CH3 dot plus Cl dot A, and this carbo cation is a formation. That's a CH3Cl in presence of that solvent medium we can get CH3 plus Cl minus A. Okay, this is the carbocation, this for the carbo anion, and that's a sorry, this for the free radical, this for the carbocation, and the carbocation, the carbo anion CH3CHO in presence of OH minus gives a CH2 minus CHO plus H2O. Actually this carbon become to the carbo anion. So it's like of the Ardal condensation reaction. Okay, so then next it's a reactions. Actual the chlorination of alkanes. That's a chlorination of alkane. Okay, alkane chlorination is based on that free radical intermediate reaction, and it's a pyrolysis reaction, and the Woods reaction. Okay, so those are that the formation of the intermediate as a free radical, and also the anti-margonic rule and cold electrolysis synthesis. This also example, and here there is a SN1 reaction and margonic of reaction, and the Friedel-Crafts alkylation and acylation also. Then the dehydration of alcohol, nucleophilic addition of carbonyl compounds. Okay, this addition, nucleophilic addition of carbonyl compounds, these all are, that is a example of formation of carbocation. And the carboanion, that is for aldol condensation reaction, and the Claisen condensation reaction, decarbonylation reactions. Those are that the example of the formation of carbo free radical intermediate formation. Okay, so the next case, it's a stability order. See this stability order of free radical. The tertiary is most stable. Actually, that is for what? It's a stability order: tertiary, secondary, primary. Very lesser for that's a methyl free radical. In the carbocation, this is a tertiary, secondary, primary, methyl carbocation, and the carboanion, the CH3 minus a primary, secondary, tertiary as a very lesser stable. It's actual stability order. The next it's a formation. It's a for this bond heterolytic fission. It's a heterolytic bond fission. Here also there is a heterolytic bond fission. This for that it's a homolytic bond fission. Okay, so the next is a electrical nature. This will become, there's a positive, this will become, there is a neutral. Actually this what this is for that free radical. So this is a neutral. Okay, sorry, this is a neutral. This will become, there is a positive, and this will become, there is a negative. This for that electrical nature. The next is a number of unpaired electron. There's an unpaired electron for this free radical containing one unpaired electron. This posium or 0, and this mu value, mu is equal to root of n into n plus 2 Bohr magnetron. Mu value here there is a 1.75 Bohr magnetron. Here is 0 and 0. Actually the stability of carboanion, this in generally the alipotic nature. This the methyl anion is more stable, second primary, and the secondary tertiary. This is the order. But in case of aromatic substituent, this the tertiary, secondary, primary, methyl anion, this is stable. Aromatic as a substituent. Okay, for example, see in the case of this molecule, this phenyl group is substituted in this CH2 minus. Okay, and the remaining two hydrogen also will become to that one phenyl group actually. Okay, so there is a CH here. I can representing in the pi bond also 1 2 3. Okay, so this is secondary, this for primary, this for that secondary, and see this tertiary, the C minus here, this become the three phenyl group attached to this negative charge containing the carbon. Okay, so this double bond, and here is a double bond, and in this case of here that is a double bond. this negative charge become to here, this bond is shifted here, and again shifted here, this bond go to shifted here. So this entire, this negative charge entire of 3 aromatic phenyl ring resonating. So that's why this tertiary carboanion of the phenyl substituted or aromatic substituted like a compound will become more stable. So there is a more stable free radical intermediate, sorry, more stable carbanion intermediate. In generally carbanion for that primary, secondary, tertiary, like that. In exception in this case, the aromatic if substituted containing the tertiary, secondary, primary, and at least there is a methyl free carbanion, like that, because of due to that more resonance, there is a more resonance, there is a more stable, more resonance effect will become to the more stable. So for that reason there is a tertiary as a more stable, and the secondary very lesser for that the primary. So it comparatively very less for that without aromatic substituent. In this case of methyl carbanion is very lesser. In this only most of the students are confusing, as well as the very clear point you keep it your mind. If the substituent of aromatic ring is directly attached to the into the carbanion of carbon. Okay. Thank you to everyone. Like and subscribe and share your friends. Okay, thank you.